Hello, my name is Norman Pearson. I'm the Assistant General Manager at the Comfort Inn and Suites and the Holiday Inn Express in Wadsworth, Ohio. I've had Mr. Matthew as a teacher since in high school between 2009 and 2012. He was my programming teacher and the robotics teacher and my physics teacher for my senior year. One of the best things about the programming classes that I had in my freshman year with him is it was the earliest example of practical real-world use of, for example, maths and other things like that. It definitely was a great example of problem solving. There was before that point in school there was no better way of learning problem solving in a practical use. Outside of school was the only other way. And then the robotics program was excellent. I get to put together that programming that I learned freshman year to learn different languages. The programming was C#, and then I get to expand that to C++, a derivative of C called Robot C, and also Java. I then went on to use those at the University of Akron when I graduated from high school. That was definitely those classes were definitely some of the best examples of using problem solving and practical uses of math I've had in my life, and they were definitely very beneficial to my careers after high school and the University of Akron.
Hello, my name is Cole and I'm a former student of Mr. Matthews. I graduated high school in 2015. From there I went to Ohio University, and I graduated from there in 2019 with a bachelor's degree in accounting and business pre-law. And now I'm a licensed CPA in the state of Ohio. Back in high school, I had Mr. Matthew for a robotics class, but my brother had him for robotics as well as some computer science, computer programming. And we had similar outcomes from our experiences, although we went on different career paths later in life. The biggest things that I learned from his class, honestly, aside from the class just being enjoyable and being fun, I learned how to work as a team, and I learned how to problem solve in them as well. I think that's kind of a staple to how Mr. Matthew teaches. We'd be grouped into these teams, and you're given a problem to solve. And in particular, to us, it dealt with robotics. And that's challenging to do. You have to learn how to play to each other's strengths, and meet that deadline, right? The deadline's not going away. So when that deadline shows up, you either got something or you don't. And honestly, that's the same in the accounting field. We work in teams with varying degrees of experiences. And the only way for us to be successful and actually meet client deadlines is to be able to work together as a team. And at times problem solve and work through crisis together. So really, whatever path that you choose to take later in life, those are still crucial skills that you need and you will find applicable.
Hi everyone, my name is Lazar Vilimanovic, and in 2012 I was in Mr. Matthews' robotics and programming classes at Highland High School. In those classes I learned many skills which has helped me get to where I am in my career today. I was on the VEX robotics team that qualified for the World Championships in Anaheim, California, and used those skills to learn problem solving and dedication to my interest in engineering. After high school, I went off to Ohio State and got a degree in electrical and computer engineering. There I graduated in 2017 and then was recruited to go work at Tesla in Austin, Texas, where I worked my way up to be the lead electrical engineer for paint and plastics for both the Model Y and the Cybertruck. I was there for a few years and then moved back to Cleveland, Ohio, where I'm from, and have been at NASA for about 2 years, where I'm an electrical systems engineer, where I design electrical systems pertained to NASA's current mission, as well as research and development. I believe that it wasn't for those courses I took in high school, I wouldn't have such a strong interest in engineering. And I thank Mr. Matthew for teaching us the skills at an early age to help work towards where I am in my career today. Thank you.
Hey everyone, quick introduction. My name is Chase Fonte. I'm a former student of Mr. Matthews' programming and robotics courses of about 11, 12-ish years ago as I record this video. Today, I work at GE Aerospace within their insider threat and digital forensics team. On this team, it's within information security, if you've ever heard of that field before. On this team, we run investigations into activities that could pose or do pose threats to the company and the assets that the company holds. And this includes both technical and non-technical, from working with attorneys to archiving data, the hands-on investigation of sifting through the data, building the story and presenting it so it's understandable. And now, I'll be honest, I don't remember all of what Mr. Matthew taught us. However, that's more on me. But two very important things I do remember learning, which helped me and still continue to help me to this day. The first one is learning how to read syntax, read the language, and understand like whatever programming language you're reading or you're writing is more or less logically thought out. And when you learn one of them, it's not a one-to-one translation to other languages, but it makes other languages is easier. Now, you have to also understand, and this is what, diving deeper into that programming is largely bringing in data, transforming it, and moving it along. And there's just different languages in how one can interpret doing this. And that was really important to learn from this class. It made approaching programming less intimidating when you just keep it in the back of your mind that, okay, I just need to figure out how to bring this data in. What is my goal and how I want to, transform it or manipulate it that accomplishes the solution that I'm trying to solve. And it's iterative. So don't, try and work through the entire thing all at once to then get to the solution. You build your way towards it. And I've found that I can program faster by doing that, is like by building and testing and building and testing and building. And like then you have your bigger solution. Now, the second thing I learned in his class is something called tutorial hell. Now, what is tutorial hell? This could be used in it's definitely used in programming, but it could be applied to like a broader sense of just problem solving in general. Tutorial hell is where you have a problem that you're trying to solve and you go and look up a tutorial on how to solve it. Now, there's a time and a place for tutorials, and I'm not saying don't use tutorials, because if you have like something that's urgent that really needs addressed, you might not have enough time to kind of sit there and struggle with it, right? But so what tutorial hell is when you go and look up a problem and someone just gives you the answer to something, which is great if time is not of the essence, but you don't learn really how to solve that. Someone just gives you the answer to it. And what that tutorial doesn't teach you is all the, I hate to call it failures, because they're not necessarily failures. If it took whoever's building that tutorial 10 different pathways to then try and find the answer, right, on the 10th pathway, those 9 other attempts are different teaching lessons. And when you're programming, that iterative, like small little build and then test and build and test, that's you just making these different pathways trying to solve something. And these little details all add up. It might not solve the immediate, problem you have at hand, but it's giving you exposure to solve future problems. Because you'll go, oh, well, I, went down this rabbit hole and I figured out how to do X, Y, and Z because I took the time to, just hit all these different pathways trying to solve the ultimate problem. And you'll start realizing that, hey, I've seen that before. And the reason why you've seen it before is because, you might have solved it on your 10th try, but on the 8th or 7th try, you found the solution to something you didn't know you were going to need in the future. That was long-winded of trying to explain that it is okay to sit and struggle working through a problem, because that, like for me personally, it both is irritating because it's annoying to sit there and continuously just work through something, but at the exact same time, you're learning a lot when you do that. Like that is, like I felt like what's burned into my memory the best is when I have to struggle through something. So it's like a double-edged sword. You gotta like take the pain and the lesson at the same time, but it makes it way easier to recall it in the future. I promise you that. So I'll just wrap this up by thinking about your career and your future kind of like a house, like your dream house, and you get to build it how you want to build this house. But the house has to be built on a good foundation, or it's not going to be able to stand up to inclement weather and whatever might get thrown at it. And the education that you're learning now is part of the foundation that just makes it easier to build the house, the career that you want in the future, because you'll go, oh, I've seen that before. And the second and third and ninth and 15th times that you've seen something, it just gets easier and easier and easier as you do it. So don't let that be a barrier in your mind, that because you haven't done something before doesn't mean that you can't do it. It just means like the first time you do it might be the hardest time, and it gets easier and it gets easier. So you just got to keep that in mind, and what you're learning now is the foundation for your dreams to be put up on. So just keep that in mind. This is a great class, and Mr. Matthews is a great instructor, and I'll see you in the next one.
Hello, everyone. Today, I'm going to talk about my journey from being in robotics to working on clean water projects throughout the world. My name is Patrick Sowers. I'm a professor at Ohio State University. So my robotics journey got started in high school. When I was a junior, I got involved with what's called First Robotics, where we worked on building and programming robots. For this particular challenge, we were working on building a robot that would play a form of basketball. This was my first exposure to programming, sensors. I had some experience with the building and mechanical side, but had never really gone into the kind of electronic side. So that year we were able to travel to 3 different regionals and ended up going to the World Championship in St. Louis. And then my senior year, I was also involved with what's called VEX Robotics. We also went to the VEX World Championship, where this robot, we were working in small groups with a smaller size robot to program and build to pick up different blocks and place them in goals. And I was able to travel out to Anaheim, California to compete within the World Championship. So this exposure to robotics and the kind of programming STEM world really opened up a lot of opportunities when I came to Ohio State as an undergraduate student. And without this experience, I don't know if I would have been exposed to all the different career paths and then ended up doing what I do now, which I'll talk a little bit about. So what do I do now? My time in robotics was almost a dozen years ago, but now I'm what's called an assistant professor of professional practice in engineering for sustainable development realm. I'm also the faculty lead of our humanitarian engineering program, with my focus areas are sustainability, engineering education, and WASH, which stands for water sanitation and hygiene. A lot of my work now is around water treatment, water access in rural communities. So I did all my degrees at Ohio State. So I came in with a civil engineering degree and what was called the humanitarian engineering minor. My master's is in biological engineering. And then my PhD is out of the food, agricultural, and biological engineering department. So this engineering for sustainable development realm, the way I describe it is teaching students how to solve complex societal challenges. We have an engineering for sustainable development specialization, a minor, community-based learning courses where we travel to different communities around the world and work on different technical challenges. And then the course that I mainly instruct is called the Global Capstone Design Sequence, where students work on community impact projects with our partners around the world. So one thing I like to say that all engineers are humanitarian engineers, right? Thinking about the impact of design, of coding, of a program, of what is that impact on humans, on the community, on the environment. Particularly do a lot of work in technology development, water, agriculture, and food supply. And these programs are getting more and more common around the world and in the US, with Ohio State's program growing over the last about 5 to 10 years. So some of the projects that I've worked on and work on currently, lots of projects here in Columbus, Ohio, number of projects in Latin America and Honduras and Guatemala, and then spent a significant amount of time in East Africa working on different projects. Here's an example of one of those projects in East Africa, where we're working on a rainwater harvesting system for a rural Maasai community. And then the project that I spend the most of my time now that has a lot of overlap with kind of the stuff I started early in the robotics world is called Agua Clara, which is a water treatment programming software where we are able to design and replicate water treatment facilities like the one you see in the middle of the screen there, almost instantaneously. So using a program called Onshape, we are able to code in the water treatment equations and it will spit out this water treatment plant. Now, why this is very valuable is that as part of this ecosystem that we work with, we're with Cornell University, New Jersey Institute of Technology, university partners internationally, and then a number of different communities. One of the biggest barriers for rural communities to have these water treatment plants is the cost and time it takes for the engineering design. So by using this programming software and this process, we're able to cut the design time from sometimes 1 to 2 years, almost into about 30 seconds. So for me, that was where I wasn't always highly interested in the coding elements. I was always more interested in the physical pieces. But then as I saw that we were able to greatly reduce barriers to access to clean water, I got more and more interested in how we could use that to help solve some of these challenges. So the work that I do here now at OSU revolves around modeling these different water treatment plants and then optimizing them within the lab, within our research. So on the left side of the screen, you see one of our research stations where we're looking at kind of investigating different types of processes and then informing the model with our findings, all around providing safe water on tap to various communities globally. So that's just a quick insight into my journey around engineering and how what started a long time ago in the robotics space has ended up kind of weaving itself into my career. Now, while I don't build many robots these days, I still take those lessons that I learned during that time with me. And if you have any questions, feel free to email me. Thanks so much.